we are going to find, we are going to find the equation of the polynomial function that has these qualities, okay? So I know that my y-intercept is at 0, -12. I know I've got 3 x-intercepts. My degree is 3, which is good. I don't have to worry about anything weird and funky going on. And then my end behavior is going to tell me something else as well. So I want to start off with my x-intercepts. So my x-intercept, if my solution, or my 0, is at -3, that means that the factor is x plus 3. Okay? So remember, change your sign. If your solution or 0 or intercept is at 1, that means your factor is x minus 1. And if your solution, your 0, your x-intercept is at 2, that means your factor is x minus 2. So I've got some beginnings here. I've got the start of what I'm looking for. So I've incorporated all of this. By default, I incorporated this because my degree is 3 and I've got 3 distinct factors. So the only things I've got left to do are my end behavior and my y-intercept. So I'm going to take care of the y-intercept next. That gives me, I have an x and a y. And if my y is -12, that means my x must be 0. So I'm going to fill in my x's with zeros and force whatever's over here, which means I need a coefficient of a. All right? So that a right there is going to help me decide what goes here. Is there a lead coefficient that's negative, positive? Is it 7? Is it 2? You know, what is it? I don't know. So I'm going to take -12, which I got from here. I'm going to put zeros in for my x's, and then I'm going to introduce this coefficient right here, which is what I'm trying to find right now. So order of operations say to do what's in the parentheses first. So make sure you keep this as a multiplication problem. So I've got a -1 times the -2 is a 2. Times 3 is 6. So I've got a -12 equals a times 6. And now I need to get a by itself. So I'm going to divide both sides by 6. So I get -2 is my value for a. So I'm going to come up here and put a -2 in front of the whole thing. And now I want to make sure that my signs are in the right thing. So what this part said, I've addressed this and this and this. Now I need to make sure that this is taken care of. So as x goes to the left, his little arm goes up to positive infinity. As x goes to the right, his little arm goes down into negative infinity. And so that means it got flipped. That means it needs to lead off negative. So this is the actual equation for the polynomial function that has those qualities right there. So let's try it again, and this time let's work from what we have. That was my daughter calling, and I forgot to silence my cell phone. Yes, her ringtone is Spider Pig. All right, so I have, what do I notice from this cool picture? Because if I can pull this information off of this cool picture, I will be able to find out what the equation is. So first of all, notice that his little arms are shooting off in different directions. So I know that this is an x to the odd. Okay, I also know it didn't get flipped. So I know that my end behavior says as x goes to the left, the function drops down into negative infinity, and as x goes to the right, his little arm goes up into positive infinity. So that's what I know about end behavior so far. So to the right, he goes up, and then to the left, he goes down. What else do I know? He's got 1, 2. He's got 2 turning points. So your degree, your least degree, is going to be 2 more than the number of turning points. So if I've got 2 turning points, this must be a 3rd degree. And that's confirmed by the fact that I've got 3 x-intercepts right here. Okay, so my x-intercepts, so this is end behavior, which we don't have to write down, but we're going to. My x-intercepts are going to be where? Hang on, I don't know. I've got one at -2, I've got one at 1, and I've got one at 3. So my x-intercepts are at -2, 1, and 3. Okay? What else do I know? I know I've got a y-intercept at +3. So my y-intercept is going to be 0, +3. So with that information, I figured out I was given y-intercept, I was given x-intercepts, I was given end behavior, and I deduced that my degree is 3 based on the number of turning points. So my number of turning points, I had 2 turning points, and I also had 3 x-intercepts. So I'm going to go ahead and mandate that this thing has a degree of 3. So I now have all the information that I had before. So we're going to go ahead and set this thing in motion. So I'm going to do my x-intercepts first and put those into factored form. So if my solution or my 0 or my x-intercept is -2, that means my factor is x plus 2. My solution intercept 0 is 1. My factor is x minus 1. And if this is +3, my factor will be x minus 3. So I've taken care of the x-intercepts and the degree at the same time because I've got 3 of these going on. Next thing I want to look at is my y-intercept. So I have an x and a y coordinate. So I'm going to have 3 equals a times 0 plus 2, 0 minus 1, 0 minus 3. Okay? So I just took this point and I put in zeros for my x's, and I put in a 3 for y, and then I'm going to figure out if there's a lead coefficient I need to worry about or not. There may not be. There might be. I don't know. So I have 3 equals a times 2 times -1 times -3. So 2 times -1 times -3 is 6. So I have 3 equals 6a. Divide both sides by 6. And I get 1/2 is a. So my final answer for this is a 1/2 equals f of x. So that is how it got stretched. Notice that my little arms and stuff are going the correct way. I'm leading off positive. So as I went left, I went down. As I went right, I went up. And I'm leading off positive, but with a 1/2. Okay? So let's try another one. We have... Okay, so I have this problem, and I'm going to do this one, and then hang on, it's going to give me 1, 2, 3, 4, 5. Okay, so we're going to do the rest in class. Why? Because it is already 8:30, and I'm just now doing these. All right, so what I have is this. Look at your turning points. I've got 1, 2, 3 turning points. So remember, your turning points are your peaks or your valleys. So I've got 1, 2, 3 of those, which means my degree, the smallest degree it can be is a 4th degree. So I have a 4th degree of 4. That's also confirmed by the fact that I've got 1, 2, 3, 4 x-intercepts. So my degree is 4, my solutions are 4. Okay, so what are my x-intercepts? My x-intercepts are going to be at -3, 0, at -2, 0, at 3, 0, and at 4, 0. Okay, so I got one at -3, -2, 3, and 4. My y-intercept is at -3. So my y-intercept is going to be at 0, -3. And then my end behavior, his little arms are going down. So you know it's an x to the even because your arms are shooting off the same direction. We already figured out it's an x to the 4th. And then what am I going to do from there? I know that they're both going down. So this must lead off negative. So it's going to lead off negative. That's what that says. Leads off negative. So when I finish this, I just need to make sure that that's what I come up with. Okay, so what am I going to do first? Deal with your x-intercepts first. So if I have a -3 for a solution, my factor is x plus 3. -2 for a solution, my factor is x plus 2. 3 for a solution, my factor is x minus 3. for first solution, my factor is x minus 4. So this is what I've got so far. Now I'm going to use my y-intercept to push things where they need to go. So I have a negative 3 equals a, and then I'm going to put zeros in for my x's. So 0 plus 3, 0 plus 2, 0 minus 3, 0 minus 4. So negative 3 is a times 3 times 2 times negative 3 times negative 4. This is going to be a big number. Negative 3 is a. This gives me 6 times 12 is going to be 72. Okay, so times 72, and then divide both sides by 72. And that's going to reduce by 3. Okay, so I'm going to end up with a negative 1 over, I don't know what that is. Hang on, kill that off. I get 6 times 4 is 24. So I get a negative 1/24 is a. What did I just do, you ask? I could have divided both sides by negative 3 to start with, and that would have given me a 1 here. And then I could have divided both sides by 24, and it would have reduced it along the way. All right, so I now know that my a is what? Negative, which corresponds with this. So I've got a negative 1 over 24, and that's going to equal my function. So that is the formula that will give me this function. All right, let's do another one. So we have, hold on, what do we have? I'm trying to flip the paper. It's not working. Okay, so what do I notice? Both arms are shooting up in the air. So that means that this is a positive x to the even. It is a positive x to the even. And this one and this one both are going to be a little bit different. Let's go ahead and do them. All right, because if this is an x to the even, how many turning points do you have? You've got 1, 2, 3 turning points, which means your degree is one more than that. So this is a 4th degree, and it's going to lead off positive. Okay, so here's what I know so far. My degree is 4. Degree is 4. It's going to lead off positive. So my lead coefficient needs to be positive. You cannot see because it is fuzzy. Okay. I need to know what my x-intercepts are. And this is why I say it's a little bit weird. So I've got an x-intercept at negative 4, negative 2, and 3. So negative 4, negative 2, and 3. But I thought if my degree was 4, I needed 4 of these. And I only see 3 of them. So here's how we're going to handle this. Notice that this one touches the axis once. Notice that this one touches the axis once. But notice that this one, if you look at just that little part right there, he looks like a parabola. So we call this multiplicity. So that 3 is going to occur twice. Okay? So because this looks like a little parabola right here, that 3 is going to occur twice. So when I write the factors out, I'm going to square him. So what did I say? Hang on, let's find out what the y-intercept is. And so my y-intercept is at 3. Let's deal with 3's. So is it 0, 3? Okay, so we're going to start looking at this thing. So here's how this is going to fix itself. If my solution is at negative 4, that means I have x plus 4 for a factor. If my solution is at negative 2, I have x plus 2 for a factor. If my solution is at 3, I have x minus 3 for a factor. But I only have 3. I need 4. So where do I get the other one from? And that's where I get it from, is right here. He still hits once, but it looks like a little parabola right there. If you look at this, just that little portion right there, it looks like a line. Okay, so he's an x plus 4 to the first. If you look at just that little part right there, it looks like a line. It's not a line, but it looks like a line. And so that's an x plus 2 to the first. If you look at this little part, he looks like a parabola. So he's going to be an x minus 3 squared. So now how many factors do you have? You've got 1, 2, 3, 4. So my degree is 4, and I've got 4 factors. All right, so if this is the start of what I've got, now I'm going to introduce my y-intercept. So I have a 3 equals 0 plus 4, 0 plus 2, 0 minus 3 squared. And I need to incorporate that a out front to find out if it's been stretched or compressed, which you don't know what that does yet, but I just told you. Okay, so what do we have here? I have a 3 equals a times 4 times 2 times negative 3 squared. Okay, so negative 3 squared. So 3 equals a times 8 times 9. So negative 3 times negative 3 is 9. So here's your 8, and here's your 9. So that gives me 72. Look, it's familiar again. So that gives me 72 a's. Divide both sides by 72, and I get positive 1/24. Well, what did I want? I wanted my lead coefficient to be positive to compensate for that end behavior, and that's what I got. So my lead coefficient here is going to be a 1/24, and that's going to equal my function. So that is how we're going to handle the squared version of our problem. All right, so I think we're going to stop there. And I'm going to do the last ones in class. That is what I think. And that's all that matters. All right.